Okay, this is a special Regents Review topic requested by my students, specifically on moles and stoichiometry. So let's take a look at that. We're going to go through a couple of important terms and vocabulary. As I've stressed to my students, vocabulary is very important on the Regents exam. If you know your vocabulary, you will definitely pass the exam. Chemical formulas. We have two different types of chemical formulas. When we talk about them, we can talk about in the empirical formula, which means the most reduced state, and molecular formula. That's the actual formula for one molecule of the substance of a covalently bonded compound. It may or may not be in its lowest terms. So, what is the empirical formula for C6H12O6, which is glucose? 6 goes into 6 once, so that would just be C. 6 goes into 12 twice, and 6 goes into 6 once. So CH2O is the most reduced formula. In the molecular formula here, alkanes such as C2H4 and C3H6 all have CH2 as their empirical formula. So you cannot tell from the empirical formula what the molecular formula was. Now, sometimes the molecular formula and the empirical formula are one and the same. For example, if I had C2H5, this is the molecular formula, but it is also the empirical formula because it cannot be reduced. Naming compounds. When you're naming compounds, you should be asking yourself, do I need to use table E, which is your polyatomic ions? If you're looking at a compound and they want you to name it and it has more than 2 elements, then you know that you have to use table E, and you need to find out what polyatomic you're dealing with. For example, when writing formulas involving polyatomic ions, place the group in parentheses before crossing the charges. So if I'm asking you to write calcium nitrite, calcium's +2, nitrite is -1, you're going to put this in parentheses so that when you drop the 2 is outside the parentheses. If you write CaNO2, that's not correct because then it looks like 22. You have to have the parentheses because you're saying that for every 1 calcium you need 2 nitrites. Never touch the subscripts of a polyatomic ion. They're treated as one unit. Now, if your compound is only 2 elements and it's ionic, then you're going to name the metal and then name the nonmetal and change the ending to IDE. So, for example, if the formula is SRO, this is a metal, so we're going to name strontium. Oxide, so we change the metal to nonmetal. We change the nonmetal to IDE ending. When do I need to use a Roman numeral? You need to use Roman numeral if the first element has more than one possible charge. So these are usually your transition elements. Remember that your transition elements also form colored solutions. They like to ask that, which one of the following forms a colored solution? And they are usually found in groups 3 through 12. So you have to have more than one possible charge. This charge can be found by trial and error, and you can use the crisscross method. For example, PbO2. Well, it looks like this 2 came from up here, plus 2. And you know oxygen is minus 2. Well, that wouldn't work because if this were plus 2 and this were minus 2, then it would have been PbO. So chances are then it wasn't plus 2, it was plus 4. And we'll see why. If this is plus 4 and oxygen is minus 2, then negative 2 times 2 is negative 4, and plus 4 gives us 0. So when we drop and cross on this, we would get Pb2O4, which then reduces to PbO2. So we know that the charge on this was plus 4. And then the name of this would be lead, Roman numeral 4, oxide. And as I said earlier, compounds not containing a polyatomic ion are going to end in "ide." Watch out for substances with common names. Water is also dihydrogen monoxide, but they're always going to call it water. NH3 is ammonia. This, for some reason, gives students trouble remembering. But if you remember that it's a base, you can find it in Table L on your reference table. CO is carbon monoxide. Okay, we didn't say anything about covalent compounds. When you have covalent compounds, meaning all nonmetals, you have to use prefixes. So we have mono, di, tri, tetra, penta. So on these, if the first element is 1, we just name the element. For example, CO. There's only one carbon, so we're just going to name it carbon. If the second one is 1, we're going to use the prefix mono, like we did here, but we can't have monooxide. We can't have two vowels next to each other, so we're just going to drop one. If I had CO2, what's happened here? If I had CO2, then this would be carbon, and then I would use the prefix di for 2, dioxide. If I have N2O4, this is going to be dinitrogen. Tetroxide. Now usually it's tetraoxide, but we can't have an A and an O next to one another. So remember to use your prefixes on covalent compounds. Let's take a look at stoichiometry. Stoichiometry is simply the math that we use in chemistry to solve problems dealing with formulas. Formula mass refers to the mass of one atom, molecule, or formula unit. It's found by adding up all the masses of all the elements in a compound, and we can do this right from the periodic table. This is usually written as, when you're doing formula mass, it's usually written as atomic mass units, AMUs. So I have 2 aluminums times 27. I have 3 sulfurs. This is distributive property of math times 32.1. And I have 3 times 4 on the oxygens, 12 times 16, which is 192, and I added up. And there would be 342.3 units, or 342.3 AMUs. Gram formula mass is the mass of 1 mole of a substance. Remember, Avogadro's number is 6 times 10 to the 23rd. It's really 6.02 times 10 to the 23rd molecules or atoms. Found by the same method as above, except the answer's in grams. This is called the gram formula mass. So both the formula mass and the gram formula mass are found exactly the same way, except for this one has units of grams and this one has units of AMUs. Mole, mass, mass, mole conversion. You can use the formula. Number of moles equals the given mass, we should have given mass here, over the gram formula mass. Include units both on the setup and in the answer, and make sure the answer is to the correct number of sig figs. So I'm going to show you two ways to do this problem. How many moles of NaCl are in 15.7 gram sample of NaCl? So they're asking for moles. We don't know this. 15.7 is our given mass, GM, and you can calculate the gram formula mass of NaCl. Okay, so sodium is 23 and chlorine is 35.5, so that gives us 58.5 grams, which you see here, the GFM. So, using our formula, number of moles equals given mass, 57.5, divided by 58.5, we get 0.268 grams per mole. The other way you could have done this is simply by using dimensional analysis. We have 15.7 grams, and you know that 1 mole of anything is equal to the GFM. So we want units to cancel, so 1 mole equals 58.5 grams. Grams are in the bottom, so they cancel with this, and it's the same thing, 15.7 times 1 divided by 58.5 is going to be 0.268 grams per mole. Oh, that's moles. Sorry. This is going to cancel, and the answer will just be moles because our grams cancel. Moving on. Percent composition. Remember, this is part over whole times 100. The most difficult thing that you guys forget, I'm just going to make something up. Let's say I want to know the percent of oxygen in H2O. So this is going to be percent equals part. My part is my oxygen, which is 16 grams, over my whole, which is the whole thing, which is going to be 18 grams, and then that's going to be times 100. So 16 divided by 18 times 100 is going to give me 88.89% because it's 88.8 repeating. And that's the percent of oxygen in water. Now, let's say I change this and I say that I have a substance that is 88.89% water. What is the percent of oxygen in the water? So now this is what you have, and you're given the problem, and you have to solve for X. This is where you guys tend to fall through the cracks. Remember, you have to get rid of this 100 first. Okay? Divide both sides by 100. Cross these out. Now if you want to cross multiply and divide, you can. You've got 100x equals 88.89 times 18. And you'll still come out with the right answer. But you've got to divide through by that 100 first. That 100. You have to divide through by that 100 first. Percent of water in a hydrate, it uses the same formula. Percent water in a hydrate, mass of water over mass of hydrate. The only thing that you have to remember is you have to subtract the weight of the crucible or the dish. For example, a sample of Epsom salt has this formula: magnesium sulfate hexahydrate weighs 5 grams. After heating the anhydrous salt, meaning without water, it weighed 2.44. So this is the amount that I'm starting with. This is the hydrated crystal. This is the anhydrated crystal, meaning the salt minus the water. So the difference between the two is 2.56, and that's grams of H2O that was driven off in the heating process. Therefore, the percent of water in the hydrate is 2.56 divided by 5 times 100. Empirical formula to molecular formula. Remember that the molecular formula is a multiple of the empirical formula. Calculate the mass of the given empirical formula and divide it into the molecular mass. So basically, I went over this the other day. First thing you need to do is find empirical mass. The second thing you need to do is divide the molecular mass by the empirical mass, which will give you a multiple. And you're going to round that multiple to a whole number. The third thing you're going to do is take the empirical formula and you're going to multiply it by the multiple to get your answer. So here they're saying a compound has the empirical formula of CH2. First thing I want is the empirical mass. 12 and 2 times 1 is 2, so the empirical mass is equal to 14 grams. Has a gram molecular mass of 42. So this is our molecular mass. So 42 grams divided by 14 grams is going to be equal to 3. So my multiple is 3. Then I'm going to take CH2, multiply it by 3. 3 times 1 is 3, so this is C3. 3 times 2 is 6, H6. And there's my answer. Equations. We need to know various equations. Remember that reactants are always on the left, products are on the right. Synthesis is like marriage. Don't write marriage on your exam, but just to help you remember what it is. Two things coming together, united to form one product. Here's an example of H2 and O2 uniting to form water. Decomposition is like divorce. You have one thing splitting up. So AB splits into A plus B. Water splits into its constituents, hydrogen gas and oxygen gas. Single replacement. Remember, something gets kicked to the curb. When we talked about this in class, we talked about a couple. Okay, so here's a couple, you and your boyfriend, you and your girlfriend, BC. A new hottie moves into the school. Here's A. When we look to take, a new friend or a new boyfriend or a new girlfriend, we look to raise our standards. So A has to be better than B in order to push B out. So A pushes B out, B gets kicked to the curb by itself, and A takes B's place. Now we can use table J to do this. You want to use table J. Just like we talked about, you have to be more reactive, have to be better off. So the element pushing in has got to be higher up on table J than the element it is pushing out. Now, if you have a metal, okay, metals are positive, So positive pushes out positive. If you have a nonmetal, nonmetals are negative. So here, X is a nonmetal, it would be pushing out Z, and Z would get kicked to the curb if it was more reactive. Here's an example. Cu is above Ag on table J, therefore Ag gets kicked to the curb, and Cu can take its place. Cl2 is above Br on table J, therefore Cl pushes Br out, Br gets kicked to the curb, and Cl takes its place. Double replacement reactions. It's like two couples and they switch partners. So here you have A plus B, AB plus CD. Therefore, positive hooks up with negative, and so A is going to hook up with D, and then positive C is going to hook up with negative B. Here you have NAs plus, CO3 minus, Ca plus, and NO3 minus. So Na is going to hook up with the NO3 for a positive and a negative, and Ca is going to hook up with CO3 for CaCO3. How do you tell if a double replacement reaction will go? How do I know if this reaction will take place? You're going to use table F. If one or both of the products is insoluble, then the reaction goes. So this is aqueous, but the CaCO3 is going to form a precipitate. The reaction will also go to completion if a gas is formed or pure liquid, like H2O. Combustion, you have to know this. Some type of carbon compound. It could be ethane, ethene, alkane, alkene, anything. If you have oxygen, you're going to produce carbon dioxide and water. This is combustion. So here they're using an example of ethane. It's not even ethane. This isn't the right formula. Okay, this should be C3H8. So therefore, let's rebalance this whole thing. C3H8 plus O2 yields CO2 plus H2O. So C3, so this is going to be a 3. H8, this is going to be 4. So that's going to give me 3 times 2 is 6 oxygens, plus 4 oxygens is 10 oxygens, so 5. Okay. This wasn't a good example because C2H8 is not a good compound. There we go. Okay. Balancing equations. The number of atoms on each element on each side of the number of atoms of each element on each side of the chemical equation must be equal. This is referred to as conservation of matter. It's very important. What I start with, I must finish with. Stoichiometry, a balanced reaction, gives the ratios in which substances will react and the ratios in which substances will react, and the ratio of the products that will be made. Balanced equation gives the ratios in which the substances will react and the ratios of the products that will be made. If the one amount of substance is known, the amount of the other substance can be found by using ratios found in the equation. For example, here's a balanced equation. How many moles of O2, so I'm going to put an X over O2, must react with excess hydrogen to make 5 moles of H2O. Now you have a proportion already set up. You have X over an unspoken 1 in front of the O2 equals 5 over 2. Cross multiply and divide. 2x equals 5, or x equals 2.5. Easy to do. Law of conservation of mass. The sum of the masses of the reactants must equal the sum of the masses of the products. So, I'm going to rewrite this example down here. If I had 2 grams of H2 and the mass of O2 were 32 grams, so this is 32 grams, then what would be the mass of my products? Remember that this arrow is like an equal sign. So 2 and 32 equals 34, so then this must equal 34. Whatever's on the left of the arrow must equal what's on the right. And that is the end. A brief overview of moles and stoichiometry.